Hello, my name's Tanner, and welcome to the Codexplore podcast. If you want to skip through this introduction, I'm going to leave a little timestamp in the description that you can go right to the interview portion of it. So Codexplore is a programming education platform, tries to focus on open sourcing education. I'm trying to make it so as much content as possible is free and available for anyone, so anyone who wants to learn how to program can, even if finances are in the way. They should still be able to learn as much as they can to become a programmer. So I may eventually find a business model where I have some paid content in addition to free content. It wouldn't be to the point where it's just basic information that's for free, and then anything that you really need to learn how to program is paid. There will be enough free content that nobody needs to pay in order to learn how to program. It would just be additional items. So that's one idea I'm playing with. Another one would be a pay-as-you-go model where people could just pay like they feel, with no real necessary payments. I'm not a fan of the subscription model, really, where it's, pay $25 a month and you get content just because there's a lot of platforms doing it. There's a lot of information. So if you really wanted to get all of the information from all these different platforms, you'd end up probably spending, $500 a month or more, which is, will then prohibit you from learning. So this will just be a free platform with potentially some additional paid content. For example, we have a book right now. It's a full stack web development book focusing on Python and Django on the back end. It's for free if you go to www.codexplore. That's codexplore.io/books. You could read it for free. I'm working on an open source publishing type idea as well. So there's a GitHub. If you have any ideas to change it, feel free. At this point, we have a Patreon. It's only for people who can contribute. Don't worry about contributing at all if you don't want to. I want to stay away from advertising as well. So any suggestions for a business model from people listening would be great. And just want to say that as I'm trying to create this business model, I may mess up along the way. Not really sure how the best avenue to go about this is, but hopefully I'm going to figure it out sooner rather than later. Like I said, all of our content is free right now, so if you go to it right now, we have blog posts, we have that book I was talking about, we're going to have podcasts, including this one, and then we'll have some video tutorials as well. At this point, you don't need to make an account to access any of it. I'm really opposed to that. It's just another account, more passwords that you have to memorize. So you should be able to get all the information for free without having to create an account. And if you want to get information when new things come out, you can just subscribe and you'll get an email, but you won't need to log in or anything. You can also follow us on Twitter. It's at Codexplore_IO. That's CODEXPLORE_IO. All right, so now let's talk about the Codexplore podcast. It's an attempt to create a podcast focusing on interviews with interesting people in STEM fields. It could be entrepreneurs, authors, recruiters, just anyone in the STEM-related field who has a very interesting point of view on things. Each episode will be pretty flexible about what we talk about. We'll see what, how the conversation goes. In terms of what kind of people I'm going to get on, anyone that's really in the STEM field, that'll be interesting. I want to get on. I'm not really going to pigeonhole into, let's say, programmers or not. I want to get everyone. That's interesting. And the last piece of information is all podcast guests are going to have the right to edit it when we're done. I don't want to try to get any gotcha things. I mean, we're not talking about anything too crazy, but if they say something that they want to take back, I want to give them the right or the option to edit it. Just wanted to disclose that. So now let's talk about our guest. Percival is going to be on today. He is the author of Test-Driven Development in Python, Obey the Testing Goat using Django, Selenium, and JavaScript. He started his career as a management consultant before becoming a programmer. We talked about it a lot. We talked about writing tests in development, programming in Python and Django, Brief discussion at the end on privacy and advertising. He was super interesting. I wish I could spend a lot more time talking to him. He talked about a couple books, and I'm going to put in the description of the podcast the links to them if you are interested. So, without further ado, Harry Percival. Morning. So we have Harry Percival, author of Test-Driven Development with Python, Obey the Testing Goat. Harry, how are you?
Yeah, I'm really well, Tanner. Thank you very much for having me on.
Oh, no, thank you so much. So let's get right into it. Can you just give us a little bit of a background of, I guess, your experience, as a programmer, and then kind of how you got to that point?
Sure. Well, I wasn't always a programmer. I spent a few years as a management consultant, which is a slightly meaningless profession. And what I found is that the thing I most enjoyed about my job was making kind of overcomplicated Excel spreadsheets. And so I was doing this, and I thought eventually, I always did a bit of programming when I was a tiny kid. And I thought, you know what, I'm on the wrong career here. So I went on sabbatical, I quit my job, I did a new degree in computer science, and after that, I got a job doing Django development, actually. Okay. And that was around 2008, 2009. So maybe it's my 10-year anniversary.
Perfect. And yeah, we actually have that in common because I have a background, I started in real estate and I was doing the same thing, overcomplicated Excel models, and then started moving to programming. So yeah, that's funny.
You know what? Raymond Hettinger, core developer of Python, used to be an accountant.
Really? So,
yeah.
So I guess it's one of those fields that produce a lot of programmers, I guess.
Yeah.
So what are you working on now? I mean, do you have your own, do you have a job right now, or do you work on your own?
I sure do, yeah. So at the moment, my main job is with a British retailer called Made.com. We sell furniture and kind of lifestyle goods. And I'm part of a team of about 20 Python developers writing kind of logistics software. And that's great fun. And then on the side, I can keep the book ticking over and conferences and a bit of training here and there.
And what kind of Python, libraries, frameworks, things like that you use in your job?
So at work, let's see, what kind of frameworks? So for the kind of software we're writing is I guess what you'd call supply chain software or logistics software. We're kind of managing, we've got a website and that's it's got a shopping basket, and that's all kind of PHP and JavaScript and React and stuff like that. That's not our domain. We take over from the moment someone orders all of the rest of the stuff, which includes kind of an application for ordering furniture from the Far East and shipping it across the world. And we've got things for integrating with various warehouses, telling the warehouses who's ordered what, when it's coming in, integrating with carriers, tracking customer orders, sending emails to them, dispatch notifications, all that sort of thing.
Wow.
So there's a lot going on. It's sort of vaguely microservices kind of environment, so that kind of each individual piece is its own app. And insofar as they have web APIs, they're usually in Flask, but not always. And for the rest of it, they communicate using a kind of event-driven architecture. So there's a kind of event store system called Event Store. So the libraries we use are like for talking to that. And then we do a lot of our own kind of modeling. So the one of the techniques they use for trying to capture business requirements and capture the core of the logic of the business. So it might be logic around, how do we buy sofas from China, procurement. We have a thing called a purchase order, and we have a thing called a shipment, and a purchase order goes through stages of draft and approval and shipping and received, and then we track to changes to the ETA. And we try that using sort of pure Python, what we call domain models, and then we map it to a database later using SQL Alchemy.
Okay.
So yeah.
Go ahead. So I was going to say, it sounds like a lot of the you're kind of doing both, just internal for the business, what kind of goes on internally, and then outward facing for the customer. Is that correct? So you kind of work on both sides?
Yeah, a little bit. So most of our software is what we call back office software. So it's not directly, like, so I don't build a UI that any customers see.
Yeah.
But we do have some services that have APIs that the users see, at least indirectly. I was working on a service that does delivery options the other day. So given this shopping basket for this country and this postcode or location, what are your options for delivery? Can I get it sent to a kind of Amazon locker? Can I get it delivered to my house? If it's a sofa, what size of a truck do I need? What kind of costs are there? And that's like a little microservice that just does that. And that kind of it is an API, and that gets integrated to a front end, which is going to say, oh, here, dear customer, how would you like to have your stuff delivered?
Okay. So, I mean, we can get right into it because I'm guessing it's pretty relevant in your job given the nature of it. So test-driven development, can you tell us what that is? And I mean, I'm assuming that you're writing a lot of tests in your job because it's not something that you can just kind of go out and start doing and then debug if something goes wrong. Because then if something goes wrong, I'm guessing someone wakes up and has 5 packages on their doorstep from you. So how do you kind of go through that?
Yeah, absolutely. I mean, even with tests, there's no silver bullet. And I'm sure someone told me a story about someone receiving a parcel a full 12 months after they'd order it. Going, oh, hi, this is your table. Do you still want it? No, I don't want it. It was a year ago.
So was that an additional table, or was that just the same order?
I presume they bought themselves a new table after the package didn't show up for 12 months instead of want it anymore. But so yeah, the test-driven development is an interesting one. When I started writing about test-driven development, blogging about it, it was kind of a minority pastime. You would do a talk at a conference and say, hey, put your hands up if you do TDD, if you write tests first, and you would get 10-20% of the room would put their hands up. And I think if you do that nowadays, it's the other way around. It's like 80% of the people are putting their hands up and the rest are slightly embarrassed. So it's that's in the space of maybe 5, 6, 7 years. Yeah. So it's really something that's taken over from being a bit of a niche pursuit in the world of Python, at least, to being like kind of the dominant way of thinking about things. At least test-driven development, where you write the tests first, that's perhaps still a bit more rare. But yeah, it's something I learned at my first kind of big proper job as a developer, which was at a company called Python Anywhere. And they used a kind of development methodology called extreme programming. So extreme programming was the first of the agile methodologies, like your Scrum and your Kanban. XP was the one that was invented by a bunch of people in the 90s who said, if we look at all the things that we do when we run projects, and like all of the kind of dysfunction that's involved in that, in having like project plans and requirements gathering and documentation, and it's always crap and out of date. And they said, let's just do the opposite of everything and like turn it up to 11. And so they said, listen, we're not going to have requirements documents. We're not going to have project plans. We're not going to have long test phases, and they really wanted to do things upside down. So they're going to have, so the idea of having short iterations came out of there. The idea of saying we're not going to do the tests at the end of a long project and find out if they're broken. We're going to write the tests not just soon, but we're going to write the tests first. And they said, let's do pair programming for everything. So because we know that the best code is written when you have more than one mind looking at it, so we're just going to say, as a rule, everything is pair programmed. And so that's the extreme programming. And they the kind of core people who invented this, people like Kent Beck, who's seen as kind of the grandfather of TDD, are really the icons behind this philosophy. And here they were saying, listen, if you're writing software, like don't to know that it's working, you might test it manually, or you might write an automated test. Well, why not flip that on its head and let's write the test first? Because it's usually easier to test something that doesn't exist than it is to actually develop it. You might not know how to solve a problem, but you might at least know how to write a test that says, okay, if this is passing, then this problem is solved. And do that first, because you're going to need it later, and it will help you to write your software. That was his insight back in the 90s.
That's an interesting point of view that, if you're stuck on something, that writing a test may actually be the more efficient way just to actually figure it out.
Yeah. That's what Kent always says. He says, I may not be able to figure out how to do this, but can I figure out how to write a test for it? Yes, I can. And he says, good, I'm up and away. I'm off to the races. And I always recommend Kent Beck's book. So it's called TDD by Example. And it's such a lovely book. It has some examples in Java. It has some examples in Python. And it's really not just him saying this is a methodology and blah, blah, blah. It's much more of an insight into how he thinks and like you get a real insight into his character, and he seems like a lovely guy. But it just says that this is by doing this TDD, it just makes my life so much more relaxing. I feel like I can take on bigger challenges. Like programming is less stressful. I don't have to be so smart all the time. It's lovely.
Okay. Yeah. So let's get into the weeds a little bit more. I would say that my hesitation of, going right into tests has always been more of like a combinatorics one. How many possible things can go wrong? So how many tests would you need for every possible thing that goes wrong? So from that point of view, can you kind of, calm my mind or tell me that maybe I'm right, but it makes sense to do test-driven development, or I'm looking at it completely wrong?
Absolutely. No. It's a real problem. So we're talking about combinatorial explosion. Like if you've got an app that's building cars and they come in 3 colors, red, green, and blue. You can have like test green, test red, test blue, and they come in 3 sizes: small, medium, and large. Okay, I have test small, test medium, test large. Oh wait, but hang on, I have to do test small red, test small green, test small blue, and test medium red, test medium, and then you're going to say that they come in like diesel and unleaded and electric. And so now I have not just 9 choices but 27, and then I could add another set of features, and so you've got this combinatorial explosion where each kind of new feature might, if you're thinking I need to test this thoroughly, just multiply up the number of test cases like crazy.
Yeah.
And the kind of classic answer to that is, like what you need your code to have components which are reasonably self-contained. So maybe I've got a module for choosing colors over here, and I'm going to write 3 tests for that because there's 3 colors. And I've got a module over here for choosing sizes, and I'm going to write 3 tests for that because there's 3 sizes. And then to test that like the 2 of them work together, I don't need to write like another 9 tests. I'm just going to write 1 or 2 maybe, because now I'm not really testing that all the colors work and all the sizes work. I'm just going to check that both sizes and colors work. So that's maybe just 1 test for medium green diesel, and 1 test for large blue electric, and I've checked that everything is plugged together. So it's this kind of difference between unit tests where we're testing small units of software, and I really can go through, for this kind of self-contained unit, what are all the edge cases? What are all the weird things? What are all the things that are going to really assure me that this works properly for all the possibilities? And then when I'm gluing a bunch of things together, I'm talking about integration tests, and I should have fewer of them. Like otherwise, it's totally unmanageable. Yeah. And so that's really checking that things are glued together, and you don't need to check every possible combination to check that things are glued together correctly.
Yeah, exactly. Well, and then, is there also something in test-driven development, or just, using tests kind of like a sampling? So instead of going through a lot of different cases, you kind of take random samples to see if those work, and then you can have a reasonable expectation that the rest of, these situations will work?
Yeah, you've got to... You've got to think a little bit about how you would test it if you were testing it manually, right? So if you've built a website, what are the tests you would do manually, where you would go, okay, once you've done that, I'm pretty sure it works. So you're not going to sit there and order every single color of car and flavor and combination. You're going to probably just check 1 or 2. And so you have kind of intuitive rules of thumbs for saying, okay, well, look, I've got a thing that needs to handle adding items to a shopping basket. So I'm going to test having 0. I'm going to test having 1. And then I'm going to test having n. Like say 5. And if I can do 0 and I can do 1 and I can do 5, I'm pretty sure that I can do 1, 2, 3, 4, 5 and 100. Yeah. So you'll have some rules of thumb like that. Okay. And it's reasonably intuitive. So like the 0, 1, n is a common heuristic. And the other thing is, if you know that your code has conditions, like each time you have an if, and there's a new branch in your code, well, that probably means you should have 1 more test. Each time you have a for loop, then you're starting to think of that 0, 1, n. Okay, well, if I have a for loop, I'm iterating through the items in a list, so I just want to check, okay, well, if that list has no items, what should happen? If that list has, non-zero items, it's probably 1 or 2, or maybe I want to do 1 and n. Okay. These kinds of things are reasonably intuitive, and because you know that you don't need to test 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like just 0, 1, and 3 is probably enough.
Okay. And you had mentioned a unit test.
Yes.
Sorry, I don't know if I cut you off. If you had to finish a thought, but after that, what is exactly a unit test, and what is that? Is there a difference between that and, let's say, like a functional test?
Yeah. So there's some terminology battles out there over this, and people get more or less purist about it. To the extent that some people will just throw up their hands and say, you know what, I'm not going to talk about unit tests or functional tests or integration tests or anything. I'm just going to talk about fast tests and slow tests. Okay. So I'm going to have one folder over here called fast tests, where if I run it, all the tests run very fast. I'm going to have a folder over here where the tests are slow, and if I run them, they're just slower. And that's my distinction. The general insight is that fast tests tend to be in memory. They tend to have very few dependencies, and they tend to test quite specific things. Whereas slow tests, why is a test slow? Well, maybe because it involves a lot of moving parts, and it does have a lot of dependencies. So I can run a test over here that loads a function and gives it a class and an object and gets another object back, and I can check the attributes of that object, and everything happens in memory, and that's fast. And over here I can have a test that starts up a web server, opens up a separate Python process, opens the request library, pings that request library, and then checks that the web server is going to field a call and send an email, because I've got another thing over here that listens for emails, and I'm checking that a bunch of different moving parts are all connected together and sending messages to each other over HTTP. And the fast test runs in milliseconds, and the slow test runs in maybe seconds. And it's but so we can get a little bit more into the idea of units and integration tests and functional tests, but that's the main thing, is that some of them are kind of really testing individual maybe functions, individual classes, or individual kind of components of your code, and they're happening in memory, and as much as possible they have no dependencies. And the slower tests are the ones that are kind of testing that you've glued a bunch of things together. So like, can you really talk to the database? Can you retrieve objects from the database and save them? Can you actually present a web API or a web server or a web page in front of a user? Does it load in the browser? If I click on links, do they take you to the right place? If I click on a button, does it submit a form? If I submit a new user, do they receive an email saying welcome to mystartup.com?
Got it. And then, I mean, if I am playing devil's advocate, then I would say, okay, you have these fast tests and then you have these slow tests. So the whole idea is you're separating by efficiency, obviously, but I guess maybe not efficiency is the right word, but what about if something goes wrong with your tests, right? Do you end up having to write tests for your tests to make sure that it's actually testing correctly?
No, you'll go crazy if you do that.
Okay, so that's something that's just never even really dealt with. It's like we're gonna go in. The first step to do tests. If something's that wrong with the software, that the test is failing, and something's wrong with the actual underlying software, then we'll probably be able to see it.
Yeah, well, I think that's one thing, is that you want your test to be relatively simple and sort of boring. If you've got a kind of test that's testing a little function that's meant to, I don't know, transform some data, you're going to have some examples where, like, okay, well, this data structure should go into this function. It should come out looking like this with these attributes changed, and this one should go in and it should change like that. And your tests are kind of reasonably simple, like they have some data in, they have a kind of function call, and they have some data out maybe. And then your kind of slower tests, we might call them functional tests or acceptance tests or end-to-end tests. They're going to be doing things that are more like what a user would do. So typically, so if you've got a ticket tracker, like a Jira or something, where people are writing features, or you've got a product owner who's describing use cases for your system, they're typically going to say, well, like a user should be able to come along, and there should be a new section on the website where they can click and they can view their order history, right? And so that test as a story shouldn't be too complex. So just say, well, here's a person. Let's say they make 2 orders. Then if they go and look at the order history page, then they should see those orders and they should be able to click through to the details. So the complexity, like the thing that's really complicated, should be the system that implements, kind of a shopping basket and an order history and a whatever. But the tests should either be like the simple one. The unit test should be quite short and simple, okay. And the slow ones should be kind of in terms of what people do. So you should be able to relate to them, and they should be simple in the sense that like the user, all they can really do probably is only click on buttons and look at web pages. So
okay.
There's an interface there which limits the level of complexity maybe.
Okay. Yeah. So based off of what you just said, let's kind of get into your book. One of the things I noticed is, one of the philosophies of test-driven development is kind of giving a story to your test, not just writing a test by itself, but giving a story. You kind of went into that a second ago. Can you explain that a little bit more and what that really means?
Absolutely. I think particularly for your end-to-end tests or your functional tests, whatever you want to call them, your slow tests, they're probably going to be the ones that, all your unit tests are going to check that individual components of your software are correct and maybe do the right maths or have the right logic or whatever. But the thing that's ultimately going to tell you, I've built an application that people can use, is going to be a slow test. It's an end-to-end test that checks that you've glued everything together. And they tend to be expressed as a story. They tend to be because like what you want is you want the users to be able to exploit some new feature in some way, and so that tends to try. I mean, so like when you capture those requirements, when you have some business analysts or a product owner, or even when you're just thinking about, okay, what new feature am I adding for my startup? You're thinking, well, I need people to be able to come over here and they should be able to click on a new thing over here, and then they should be able to see things like this because they want to whatever. And so there's a story there, and you can have more structured ways of capturing that. There's the given, when, then structure that people like to use, or there's the so given, I've got an order with this many items, when I click checkout, then I should see the tax calculations. Or you can have the structure where you say, as a such and such type of user, because I want to, save money on business taxes, then I should be able to, use this sort of feature. I'm not sure I'm explaining myself here, but.
No, it makes sense.
But the nice thing is you can take these kind of these stories, which are usually kind of written down as bullet points in a document somewhere, and you can try and track them really closely to actual automated tests for your application, and know, especially if you write these tests first, you can be, if once I get this test passing, I am really going to have delivered exactly what my requirement was, exactly what the users want to be able to do. And so rather than having quite abstract features as bullet points and acceptance criteria or whatever it is, you can actually transform them all very directly into lines of test code that will pass or fail and tell you whether you've got it right.
Yeah. So then what made you write the book, Test-Driven Development with Python? I mean, part of it said that you really don't like debugging, or you're not good at it. I forgot the exact quote, but it says I'm actually bad at debugging. So what made you? It sounds like someone who's is not good at debugging. Why would they then do test-driven development? Is it kind of like a handicap you give yourself? Maybe that's not the right word, but something to kind of make sure that, hey, I don't want to have to go down the rabbit hole of debugging and spending 8 hours on different Stack Overflow threads or anything trying to figure out why there's something wrong with my code.
Yeah. Well, I mean, I think anyone who's built an application without tests. I mean, the truth, like, so my first app, I'd read a book about programming in Python, Dive into Python, it was called, which is a popular book in the sort of Python 2 days. And about sort of chat, so he explains, Python, here it is, language, data structures, dicts, for loops, list comprehensions, all the lovely stuff. And then about chapter 10, it says, let's talk about unit testing. And I think the example is a Roman numeral converter. And he goes, let's suppose you want to make a function to convert Roman numerals, you could just go ahead and do it, but what about this? Like, you can actually write tests to check that you've got it right, and check that I is 1 and II is 2 and IV is 4. And I read that and I thought, oh, that's kind of cool. And then I got my first project, and there was a client, and there was deadlines, and I was like, oh, tests? I don't know if I've got time for that. Yeah. And you know what? I reckon I'll be fine. And I was absolutely fine. I wrote this app, and I was fine at first. And so when you're building a small app and it starts out small and it's all in your head, you're okay. You've got 2 or 3 pages, you add a new feature, you reload the page, you click, you check it's there, you go, okay, fine, that's great. But as a project grows, you grow a few more pages, and then you're trying to apply principles like don't repeat yourself. And so you go, oh, okay, well, I'll have this thing, and it will inherit from this other thing. I'm going to have an inheritance hierarchy, and now maybe I've got 2 classes that both feed into each other and a diamond pattern. And then you start going, okay, well, I need the new feature on this subclass, so shall I put it on the base class? Oh, wait, no, actually, because that would affect the other subclass. So now I'm going to maybe change this one, and then you're like, oh gosh, I don't know, because now I've accidentally broken the other thing, and kind of complexity creeps up on you. Yep. And pretty soon you have a code base where you're no longer quite sure what's going to happen when you change everything over here. Like, is it going to break other bits? You're not too sure, and you come to a place of kind of fear, I suppose, a fear of making changes. And you can fight that if you've got a lot of experience of programming and you're very disciplined. You can write code kind of intuitively that's going to not suffer from these problems of loads of or bits of it being interrelated. But the alternative, so the shortcut to that is, all you have to do is spend 10 years programming, and then you'll instinctively write software that's better structured and is easier to manage. But, a kind of shortcut to that is, if at least you had tests for everything, then you would feel like you can make changes to your code, and you'll know if you break things. Yep. And so then you can tidy things up. So suddenly it's no longer scary to go ahead and change a base class on which 15 different other classes depend, because you know that if you break something, a test is going to tell you. So then you always can tidy up. And so then you've got this way of kind of maintaining a nice structure and doing refactoring. And so development comes from a place that's got a lot less fear and a lot less stress in it. Yeah. So that's where it came from, and I learned it. I was open to that lesson because I'd obviously got in trouble, and I went and worked with these extreme programming fanatics, and they said, here we go, let's write tests. And I went, oh, okay, great. So we write functional tests, or high ones, and then we write low-level unit tests as well. And I complained about everything at every step of the way. I was like, whoa, come on, we're running both types of tests. That's how we need both. And then they would do this kind of style of development, which was incremental or incremental development, where you write a test, and then you don't just go ahead and write the implementation, but you'll change one line of code and then run the test again and see it fail with a very subtly different error message. Mm-hmm. And then you go and make another tiny change to the code and then run the test again. And you're like, well, this is crazy. How many million tiny steps do you want to go? Can't we just jump to the right answer? And they're like, no, look, even if we could, this is good practice when we have more difficulty. And, so I complained about all this, but after, kicking and screaming, they dragged me to seeing the wisdom of all this stuff. Yeah. And really there wasn't a lot of resources on that kind of thing in the Python world at the time, and so I thought, I would like to try and write this up and share it with people, initially in the form of a blog and a little kind of tutorials and workshops, and it later spiraled out of control and became a book.
Yeah. And then, so I would say one of the things, especially people who are kind of just getting into programming, I mean, what would you say to convince them? Because when I'm first learning, right, I want to be able to get something, I'm going to need the instant gratification of saying I'm building something and I see it. And when you're doing test-driven development, you're basically saying before you do anything or before you can see anything that you're really, with your eyes, you have to write tests for it. So how can you convince someone who, I guess, is more impatient and wants to see what they're doing faster to then write tests on top of that?
I'm just going to wait until they're in the same position I was. It's okay. You have to learn this the hard way of just wait until you're in loads of trouble. Yeah. And then when you're sitting there going, wishing you had tests, you'll be like, yeah, you do wish you had them. So in future, let's just write them first. Yeah. I mean, it's a weird way of developing for sure. So it takes practice, and it's not intuitive, because what you do want to go just jump in there and get it working, and sometimes writing the test feels like make work, or it feels like, come on, this is not what I really want to do. But once you've seen this and seen it a few times and you've seen the payoff, it's worth it.
Yeah.
And also once you get used to it, it becomes a very natural way of working. It's more just saying, sure, you want to dive in code, but what are you even going to code? What is it that you're trying to build? Mm-hmm. And when you sit there and try and write a test for it, it forces you to clarify in your mind, what is this thing that I'm trying to buy? What should the user actually be able to do? Or if you're writing a function or writing a new class, writing a test for it forces you to think of that class from the outside in. Okay. It forces you to think of it in the way that it's going to be used, rather than from the inside out, rather than from the bottom up, which also helps you kind of trying to design sane things.
Yeah, and it sounds like, I mean, if from and this is coming from someone who doesn't write a lot of tests, and I probably should, and it makes all the sense in the world. It's just one of those things that I think you have to get in the habit of doing. So, I mean, would you say that it also helps with planning the app? Like you said, not just from, knowing what the user is going to do, but just designing the actual software architecture of the project you're working on. Would you say that this is a very, very good tool to have?
I mean, it's not a replacement for design, I guess, and it's not a replacement for planning.
Okay.
So it tends to go hand in hand with a kind of iterative model. Okay. Of saying, well, so it's particularly if you're kind of trying to break things down into use cases. If you're sitting there going, all right, well, I'm going to write tests first, and the first test I'm going to write is a kind of end-to-end test, is a functional test which explains what the user is going to be able to do. It forces you to break that kind of new feature up into a reasonably coherent chunk of saying, okay, well, currently they can do this, and in future I want them to be able to go over here and click on this, and then they should see this. And it kind of restricts the scope a little bit of that feature that you're going to be building on, and gives you kind of an incremental chunk. So maybe in that sense, it's one way of forcing yourself to do things in sort of reasonably consistent incremental chunks. Okay. And then design-wise, it's not gonna give you the perfect structure, but it does help a little bit in the sense of helping you work from the outside in. And it helps in the sense of once you have decent test coverage, then you're no longer afraid of refactoring. So if you sit there and go, you know what, I'm going to change everything from functions to classes or classes to functions, yep, you can go ahead and do that. Or if you go, I mean, one of the best cases for tests, I always say, is when you find someone who's got a project and they said, you know what, we have no tests and we're fine, like the project is okay. I go, all right, Django project. When was the last time you upgraded Django, and how'd it go? And they just go, oh no, we're never going to do that, because they're because upgrading a major piece of infrastructure is a terrifying thing to do if you have no tests. Yeah. Because the ramifications are so wide and unpredictable, and flushing them all out means that I have to go and look at every single part of your app and watch your log files for possible errors. Mm-hmm. And it's a huge hassle. But if you have a test suite, it's just a matter of hit upgrade, find all the things that are broken, fix them all, and once they're all fixed, it's fixed. You can go ahead and deploy that.
Yeah. I like that point of view, especially. I mean, with Django specifically, there's guys. I don't know when the next long-term support version is coming out, but it is something that's going to be happening pretty soon for people that want to upgrade from if they're using 1.11. So yeah. So then, what brought you into Django and Python specifically?
I think my first client was someone for whom I built a few overcomplicated spreadsheets, and he was saying, well, I've got this part of the business where maybe we should have a website for this or something, and then we can put it in front of more users rather than trundling around with spreadsheets. And I said, oh, well, I've learned a bit of web development. I think I could do that. And he said, okay, well. He trusted me enough to give it a go, but it was my first ever project. So he said, why don't you collaborate with my web hosting company? Mm-hmm. And so I said, okay. And I talked to them. I said, listen, I want to do this web development project. And they said, okay, well, we like Python and Django, so we suggest you use that. And I went, okay. And I went away over Christmas, I think it was, and learned Python and Django as quickly as I could. It took a couple of weeks. And I mean, I learned the absolute rudiments, and I built some absolute horrors into that application. But but it's such a lovely language and such a lovely framework. I mean, it made so much sense. When you learn Python for the first time, and then if you know a couple of other programming languages, you just go, well, this is brilliant. Why isn't it always this simple? You know, you look at the for loop and you go, for item in my list. This is the absolute pure essence of a for loop. Exactly. And the Java and the JavaScript and the C way of doing these things is just horrific. Like once you've seen that, you're like, right, of course it should be like that. Yeah. It's the one obvious answer. And so that's a real pleasure. And then Django, you know, the tutorial is so good. I mean, you literally can just sit there, read the Django tutorial and go, right, fine. At the end of that, I understand models, I understand views, I understand, it all makes sense. And if you've done, you know, a bit of PHP or whatever at university, you kind of understand that you need to like hack together pages and a database and HTML. Django gives you a nice structured way of doing that. And so it is really about providing like some sensible, obvious answers to how should I do things, and then you can get on with solving actual business problems, kind of thing.
Yeah, and it's funny you said that. Like Python, I agree. It's such a it just makes sense, and you know, one of the jobs of like people who are in programming is trying to find the most efficient way to do things. And it's funny that when it comes to languages, it seems like the more rudimentary, like the more you have to retype, like, you know, in Java or C++, they think those are like more true programming languages. But shouldn't you want to be able to write a for loop in as little, you know, characters as possible? Yeah, and so that's why Python seems to make the most sense. And I agree that it's, you know, a great language. So, you know, I went through a few different languages. I'm not going to throw any under the bus, but Python, when I landed on it, and because it has so many different applications. I mean, have you used Python in data science at all, or, you know, outside of just web development? And obviously, you know, planning the logistics and stuff with your current position. Yeah.
So my experience in data science is limited. One of my colleagues runs a data science boot camp in the UK PyData organization. So I know all about that, but I've never done it in anger. But you're absolutely right. We've got this huge influx of people into the Python world from the data science world, where it really just seems to be converting a lot of people. Tools like IPython Notebook are out there, and that's nice to see. You know, it's nice to see a community growing so strongly like that around the fact that this language just gets out of your way a lot. Makes so much sense. There's lots of reasons to use other programming languages, and I don't know, people who love Ruby will talk about how lovely and expressive it is too, and you know, it makes for nice readable code as well. And people who love C will just tell you, no, that's all very well, but I would actually like my software to run fast. Thank you very much. And so there's loads of good reasons for using other things, but Python does have a sweet spot for data science and for you know, web development. It's got a really good story, and it's now growing into, you know, things like Made.com, where you know, companies that were startups are now finding they're like, you know, Made started with whatever it is, 10, 15 people, and there's now about 500, and it's a piece of software that, you know, they used to sell, you know, a few dozen sofas, and now they're selling, I think, some like millions of pounds a day in orders, and suddenly you've got software. It's not just a little Django app that someone's thrown together. This is a real business. It's got, you know, it's like an ERP software, enterprise revenue planning. It's got logistics, it's got accounting, it's got complex business logic. And these are things that you would traditionally you would use Java or you'd use C#. Because that's been the languages that have dominated kind of the enterprise, in quotes. But there is a new niche out there for these companies that have started out using Python, because that's the language that's the easiest, that lots of people now know from university, and it's a nice way to build your startup. And as these startups grow, you've got all these places which would have been locations for you know, kind of software that a bank or an insurance company would write, is now being written by people who a few years ago were just, you know, kind of YOLO startup developers, and it's a fun world to be in. Yep.
So then, if we were to step outside of Python, what other code stacks do you like? You know, or what other programming languages do you have experience in? Have you started to use? And, you know, what would you suggest outside of Python if people wanted to kind of expand their skill set? What is a language that, or, you know, a framework that you found to be really, really nice?
Well, everyone has to do JavaScript if they're in the world of web development, right?
Yeah.
And we had the nice experience a few years back of deciding to switch to React, and it tends to, like, React itself, people can have arguments about whether it's good or bad, but one of the things that came with that was switching to modern JavaScript, I guess. And you grow that whole complexity of the impossible, like, teetering tower of transpilers and Webpack and Babel and blah, blah, blah. Mm-hmm. But, excuse me. But once you've built that teetering tower, you suddenly get to use a different language, like modern JavaScript, as opposed to the kind of like plain old ugly JavaScript.
Yep.
And it's actually a real pleasure to program in, and even old JavaScript, honestly, like it is still a dynamic language. It's still easy to write. There's lots of nice things about it. So if that's something that any of the listeners today have been a bit hesitant about, go ahead and dive into JavaScript, plain old JavaScript, but also the new JavaScript takes a lot of the warts off of that language.
Agreed. And I started learning React recently, or just messing around with it. And I gotta say, it far exceeded my expectations. So yeah. So when you're dealing with React, do you create any like front-facing websites? Because one of the things I've heard about React, or I don't know if you know about any experience, but there's problems with SEO because search engines haven't actually figured out how to crawl single page applications yet. Do you have any experience with that or ways around that?
No, I have nothing to say about that. No.
Okay, perfect. Let's move on then. So then outside, I
would say to finish on programming languages, the other thing I really enjoyed was learning Lisp. And if you like, every so often, I mean, I've run out of time because I have stupid children and a stupid family, and so like all my copious spare time in which I used to have fun things like learning other programming languages obviously is all gone. But as programmers, we like to try and learn new things, and if you haven't done so yet, one of the great things you can do is teach yourself Lisp, or one of the Lisp-alikes. So the kind of modern popular Lisp is called Clojure, and it's a functional programming language. So if you've never done functional programming, that's very interesting. And the book to beat on this is called SICP. I think it's called the Wizard book. I might be wrong about that. In the code, but SICP, Structure and Interpretation of Computer Programs. I think it's dated 1983 or something. It's Lisp is a ridiculously simple language where pretty much there's a keyword for def which defines a function, and then there's brackets which define the structure of what's inside or outside the function, and that's it. That's pretty much the whole syntax of the language, the book is it's fun because they ask you, they kind of explain the syntax, they explain the language a bit, and then in chapter 1 they set problems, and they're these kind of weird problems where they say, like, the phrasing of the questions is weird because they go, if you were to write a program that looked like this, describe what steps the interpreter would take and describes what the output would be, and you're sort of thinking as you're writing it, like, why all the conditionals? Like, why can't you just say, like, write this program, run it, and find out what happens, and explain why? And it's because the book was written at a time where most people wouldn't have access to a computer, so they really were expecting students to go ahead and do this with a piece of pen and paper and come back with the answers on pen and paper. Great stuff, like this, so the 80s, where like most of your computers will have been like mainframes or even earlier. Yep. And like in the lessons, they would be teaching with a blackboard, and like the code would go on the blackboard, and they would write the answers on the blackboard. Hilarious. Yeah. But anyway, there's such great lessons in that book. So yeah, SICP, a real mind blower.
And what I would say, like, in today's world, what are some, like, really straightforward applications of Lisp that we may see, or that they could, someone who's wondering, why should I learn Lisp, but what could they do with it?
Mm-hmm. So Clojure is the kind of modern Lisp that everyone that's the kind of modern Lisp, I suppose. So Lisp is built into the Emacs text editor. So if you want to use Emacs, you could learn Lisp. That's a little aside. But Clojure is there. It's based on the Java virtual machine. So you write Clojure code, but it actually runs on a Java virtual machine. So anything that's available in the Java world is available to Clojure programs. And there's also a variant of it called Clojure Script, which compiles down to JavaScript. So potentially, you could build web applications with a Clojure server that actually runs on a Tomcat Java web framework server, and a front end written in Clojure Script, which is actually JavaScript, which would actually interface with React. So there are libraries for using the React framework with Clojure written in Clojure Script. Okay. So that would be a fun book if only I had more time. Is a test-driven development with Clojure. Okay. And you could you could use React with Clojure Script, and so it's just one of the many ways that you put a wrapper around kind of JavaScript itself, plain old JavaScript, and you can put another language around it that makes it more of a pleasure to write. Okay.
And then I would say on the final part of the test-driven development part, I'm going to drive myself crazy if I don't ask you this. Can you explain the testing goat?
Well, I think so. There was a thing in the PyCon is the main Python conference in the US, and they used to have a thing called a testing BOF, which was a kind of BOF stands for birds of a feather flock together. So it's a little community of interest for people who like to talk about testing, and they would get together and do little lightning talks, like sort of one evening of the conference. Sometimes there would be drinking and heckling, and it would be a sort of raucous affair. And it was at a time when people would pepper their slides with pictures of cats. And then I think someone goes, "I'm bored of cats. We're just going to do goats now. This is testing BOF. We have testing goats." And so they put pictures of goats all through their slides, and it sort of became a bit of a mascot, and it was like kind of a short-lived joke, but I think I took it all too seriously and just decided, well, that's it. So you're saying the testing goat is the official mascot of testing in Python, right? I'm going to run with it, and I think I was pretty much the only person that ran with it, really. But there you go. So testing goat, obey the testing goat was a phrase I saw on Michael Ford's website years ago. Okay. And I thought I'd go with it because I wanted to convey this idea that because testing and test-driven development is counterintuitive, it's nice to have like a little mascot for it, and a kind of mental picture of I say it's a bit like learning a martial art. You to learn a martial art, you have to do a bunch of things that are kind of counterintuitive, and you have to practice, and it's annoying, but it's only by practicing that you get good. And so you need a kind of bad-tempered and unreasonable master to sort of rap you over the head and go, "No, get back to doing your katas," and or the testing go is going to go, "No, test first." And I think of it as kind of like, in cartoons where you get a little angel or a little demon popping up over your shoulder, and so the testing goat is like the little angel, but just with a very niche set of concerns.
So just imagine when you're programming, there's a goat on your shoulder, and you'll be good.
And it's just trying to remind yourself to not take those shortcuts and to try and do it properly and to practice it. Like even when it's easy and you don't need to, like practicing and doing it properly when it's easy means it's that much easier to do things like testing and to work incrementally when you're actually facing with a really tricky problem. It's about getting things into muscle memory.
All right. And I'd say the final thing I want to talk about before we end, because I know you're busy, with everything that's going on with privacy issues, and you see things like Facebook, what is your opinion? Because if you were to ask me 20 years ago, would someone prefer to have general ads or, targeted ads? I'd say I don't want to see ads that don't apply to me. But as we're going forward, it seems more people are like, yeah, no, I want general ads because the amount of information you need to get a targeted ad is not something I'm comfortable with. So how do you kind of view that? What do you think the, best policies are going forward?
Yeah, I mean, I may be okay. Great, we're going to get into it. I appreciate this is a minority view, and I know that there's like practical considerations that make this difficult. But if I was president of the world, I would simply ban advertising. I think advertising is evil. I think it's a pollution of the collective subconscious. I feel like in my life I have never needed advertising. Like the last thing I bought because of an advert was some crappy toy when I was like 15 years old. And ever since then, I've never felt that advertising is something that's useful for me or has helped me make decisions in life. It's just spam. If I want to buy something, I will go and research it. Well, because I'm a nerd, I suppose, and the kind of things I'm interested in was like, I was interested in buying computers. Did I like watch ads for computers and go, oh yeah, I'll buy that one from the ad? No. I would go and read loads of articles about it in the newspapers. I would go and fetch all the tech specs, and I would compare features, and I would look at my budget, and I would make a spreadsheet, and I would figure out the best thing that I could buy for, so like when I make purchasing decisions, I don't care whether you've put some advert in front of me. Like I know that's just going to be lies. Why would I want anything to do with that? And we have Google nowadays. We have the internet. There is no reason to advertise at me. If I want something, I can go and look it up. Yeah. So I think that's awful. And you also, the story about, Coke and Pepsi. There's one thing which maybe you can argue that factual advertising, where you might introduce people to a product they don't otherwise know about, maybe, okay? You could conceivably have an argument about that, but most advertising is not that. It's just branding. Yep. And there's that stuff like, yes, Coke adverts, it's just the Coke logo, and Pepsi adverts are just the Pepsi logo. Maybe it's on a beach, maybe there's people wearing skimpy clothes, but whatever, it's just branding. Yeah. And it's got nothing to do with what the features of Coke are, or in what way where you find it delicious, or when would it serve a need of yours. Yep. And the story, which may or may not be true, is that one day Pepsi decided that this was all a waste of time, and so they would stop advertising, and their sales dropped 30% in 3 months. Well, yep. So what you've got there is it's actually an arms race. Like it's a general pollution of the collective subconscious, and if anyone stops, then their competitors win. So it's a direct tragedy of the commons, in the sense that we all have to keep advertising and slamming people's brains with it, because if we stop, our competitors will do it and we'll lose sales. And that seems to me like it's a perfect case for saying we need regulation. And when you have a tragedy of the commons and it's not being solved by market forces, you regulate. Or in the case of nerds, you install an ad blocker. So obviously I run ad blockers on all my browsers, and I'm always shocked when I have to go and use somebody else's computer and it doesn't have ad blockers, and I go, oh my god, you're trying to watch YouTube and there's ads all the time. I didn't realize that was a thing. Oh wow, you scroll through Facebook and half the stuff is ads. I didn't even realize. I don't have that. Yeah.
Well, no, I mean, there's a lot there. And you know what? I feel like if we started getting into this would be like a whole other podcast, which it would be. I would love to talk about that for about an hour. So this is something I could talk about forever. So, yeah, I mean, maybe we could do that at some point if you're not too busy. So I guess I know you're busy, so I want to finish up. Anything else you want to say about this? And then, maybe some information about you, your social media, if people are interested in looking at your book, kind of how they can follow you.
Yeah, sure. No, okay. I'll do a little self-promotion. Yeah. So the kind of branding of the book is called Obey the Testing Goat. So you can go to obeythetestinggoat.com. You should be able to Google Testing Goat or Obey the Testing Goat and find me. The book is now in its second edition. Second edition came out a couple of years ago, and it is available entirely for free online. So I am a bit political. I believe that as much as possible, you shouldn't copyright get in the way of people reading your stuff. So the book is available for free online at obeythetestinggoat.com, the whole thing. You can also pay for it and buy physical copies from my publisher O'Reilly, who are a wonderful, forward-thinking, open-minded publisher who are happy to see their authors publish things for free under Creative Commons alongside commercial releases. So yeah, by all means go and read that, and if you enjoy it, buy a copy or buy a copy for a friend. That would be fine by me. And then I guess watch this space, because I'm hoping to produce maybe some new content around kind of some of the architecture stuff that we do at made.com, some of the ways we use domain-driven design and some architectural patterns. So maybe there'll be some new stuff. If you're interested in kind of once you've got past TDD, how do you structure an application to try and get the most out of your tests? How do you make it so that you've got unit tests that run fast, that give you feedback on your design and your core business logic, and then you've got as few as possible of those slow tests that take a long time to run, but that really tell you how things are glued together. So I've been learning some new things about that I hope to put together soon.
Okay. Well, great. Thank you so much for being on the podcast. I really appreciate it. And yeah, have a good rest of your day.
Great, Tanner. Thank you very much for inviting me. It's an honor and a privilege, and I'm always flattered to be invited on things like this. So thank you very much. Good luck to you, and have a lovely Friday.
You too. Okay.
Bye.
Thank you. Bye.